Now, I did mention that we don't just have strings, but we also have integers. This int value type, which we use for representing numbers. And sometimes we want to work with numbers. Now, in this basic example, we just have a text. But let's say we don't just want to output hello world, but for some reason also a number. For this, I could add my lucky number variable, and again use this shortcut for creating and assigning a variable and inferring the type in one go, which is : =, and then enter my lucky number, which could be 17. I don't have a lucky number, so I picked any number. If this is an unlucky number in some region of the world, for some reason I do apologize. I just picked any random number that came to my mind right now. Now, lucky number is inferred to be of type int, as you can see here, and we're getting an error because we are creating it but never using it. Now, that's something we'll fix in a second. For the moment, we just see this int type in action here. Now, we can output it here, for example, by again using fnt dot, and now you see I'm getting some auto-completion here, println, and then here we get also some information here in this pop-up about this function, this command which we are executing here. You can close it by hitting the escape character. And I will now pass lucky number to println. And as I mentioned, println works with almost any value type, and therefore we can also pass in an int. And if we save this, hopefully unsurprising, if I open the terminal again, if I execute go run first app.go, we see hello world twice and then 17. So that's also working. And that's how we can create an integer. And as I said, it would also be an integer if it's a negative number. It's still an integer. Integers can be negative and positive, and we can also have very large numbers here. That would also work. If I now execute this again, we see that large number being output here. There are some limits at some point, but typically all those numbers you work within your programs can be represented. Here I'll go back to 17. Now, it's nice that we have integers, it's nice that we have strings, and we see some operations in action already, but especially with integers, with numbers, you also often want to perform mathematical operations. For example, I could add my even more lucky number here and assign that to be my lucky number. And here we're doing something we haven't done before. I'm using another variable on the right side of this declaration and assignment operator here. So on the right side of : to create a new value, which will be stored in this variable based on some other variable, lucky number. And I could simply add 5 to lucky number. Now the value stored in even more lucky number will be lucky number, this variable, plus 5. So the value stored in lucky number plus 5. And hence, if I now copy this line of code, and we now output even more lucky number down there, it again shouldn't be too surprising that if I run this, we get 22 as output here, because that's the result of 17 plus 5. But it is important to understand that variables can be used in operations, and not just to pass them to commands like println, but also in mathematical operations like we have it here, a simple addition with help of the plus operator. And we can, and we typically will do that on the right side of this : or the regular equal operator to then store it in a new or an existing variable. And speaking of storing something in existing variables, we can do that as well. Let's say after printing all that data, we want to reassign our even more lucky number. So now I don't want to create a new variable, but instead assign a new value to an existing variable. And we can do that by using an existing variable name and then using the regular =, operator. So not : but just =. With that, we're not creating a new variable, but we're assigning a new value to an existing variable. And therefore, of course, this only works if you are referring to an existing variable name on the left side of the equal sign. If I had a brand new variable name like this one, then ultimately, if we would try to execute this code, it would fail. If I assign a value here, you see I get an error that this is an undeclared variable to which I'm trying to assign. This would only work if I re-add a colon, because then we would again create a brand new variable. Now I'm just getting the error that I'm not using it, but we would be creating a new one. But that's not what I want to do here. Instead, I want to assign a new value to an existing one. Hence, we must not use the colon, because we want to assign to that existing one. And now here, we could again use our lucky number and maybe multiply that with 3. Now we can again copy that line of code to output this updated, even more lucky number. And now the question is, which kind of output would you expect now when we run this code here? Well, let's give it a try. Let's again run go run first app.go. And what we see is hello world twice. If I increase this a little bit, hello world twice, then 17, then 22, and then 51. And maybe that is what you expected, but maybe you also expected something else. Maybe you expected that we don't get 22 anymore from this line of code here, because we actually do change even more lucky number here. But here it's important to keep in mind that code executes from top to bottom step by step, and that means that once this line is reached and we change even more lucky number, we already did output it. So that's why we get 22 first. Before we change it, we already output it. Now we get 51 as a result down there because lucky number was never changed. That is still 17. We assign that here and we never assign a new value. Yes, we are using it in this operation, but the result of this operation is not stored in lucky number, but even more lucky number. So lucky number is still 17. And hence, when we use it down there and multiply it with 3, it's still 17 times 3. And that's why when we output the result down there in line 22, we get 51 as a result. So that's how these variables work and how we can use them in operations, and what the difference between the creation and declaration of a variable and the simple assignment of a new value is. You do the latter with a simple equal sign, and you do the former, so declaration and initialization, with the colon equal sign. Now, before we dig deeper into variables and different values and value types, I want you to practice what you learned up to this point, because we will need all these fundamentals, all these core concepts throughout the entire course and in general whenever you are working with Go. So here's a little exercise for you. Attached you find this exercise 1 zip file, which just contains the instructions text file at the moment, and you should also put your solution code into that folder then, because we'll have more exercises throughout this section here. I simply moved into a brand new project folder here. That's why the previous code we wrote is not here right now. We'll dive back into it in the next lectures. And in this brand new folder which I created, I added this attached and unzipped exercise 1 file. Now, in the instructions text file, you, find the instructions for this exercise. And here I want you to, first of all, in task number 1, create a new Go code file, add a package entry to that file, and add that main function. So basically what we did at the very beginning of this course already, and try doing that without looking at the old code first, but of course do have a look at that code if you get stuck. Now, what you don't need to do here is reinstall Go or anything like that, because of course we do already have it installed. Now, once you're done with that, in task number 2, you should create 2 new variables in that code file. And then these 2 variables should hold your first and last name. And hence you should choose appropriate names for these variables, following these conventions which I mentioned before. And you should of course then store your different names in these variables. And you should create those variables in 2 different ways, because you learned about various ways of creating variables in this section up to this point. And you should use 2 of these ways for creating these 2 variables and for storing your name values in them. In task number 3, you should then output these variable values in the command line with help of a built-in package, which we also used before in this section already. And then also run your code file as we did it multiple times in this section already, so that you can see the output in the command line. And if everything works, you should see your 2 names in that command line if you output these 2 names there. Now in task number 4, you should add 2 other variables, so 2 additional variables. One variable that holds the current year in which you're watching this course, and one variable that holds your birth year. And then you should again create these variables in 2 different ways, so just as in task number 2. And you should of course make sure that the correct value type gets used. And again, of course, also pick fitting names for these variables. In task number 5, you should then use the variables you created in task number 4 to calculate the difference between these 2 years, so basically to determine your age. Now, the age, of course, is not necessarily perfect if you just look at the years and don't look at the months, but it is good enough for now. So just calculate this pseudo age by subtracting these years from each other. And then store that age in a brand new variable, which you should also give a fitting name. You can create the variable however you want, and output the result, so the value of that variable, in the command line. In task number 6, you should then overwrite the values stored in that current year variable you created in task number 4 with the current value that's stored in that variable plus 1. And this is something we haven't done in exactly that way yet, but we learned about all the building blocks you need for that. So try reassigning a value to current year, which is the current value plus 1. And you should really calculate that next year and don't just overwrite the value stored in current year. You should reassign a value to that existing variable instead and calculate that next year. And then repeat step number 5. So calculate the age and reassign the new age to that existing age variable, and then also output that new age in the command line. And don't change any code you wrote before, really just reassign values to existing variables. Now these are my tasks for you to practice what we learned, and definitely try all these tasks and steps on your own first, but then also have a look at my solution to compare yours with it and to see how I solved this.